let me start with the fourth module. The fourth module is 8051 timers and the serial code. So in this module we are going to study regarding the two timers or the counters. So whenever you want to generate the delay means, so this T0 along with the T1 it is used as a timer. So whenever you want to count the number of events occurring outside the 8051 microcontroller, this T0 and the T1 it is used as a counter, and one serial code which is used to carry out the serial communication. Serial communication is you are going to transmit the data bit by bit. One by one you are going to transmit the data. So in this module I am going to cover the timers, counters along with the serial code. So next is the 8051 timers. So this 8051 will have the two timers. Those are labeled as timer 0 along with the timer 1. So both are 16-bit in size, and each timer it is accessed as a separate to 8-bit register of low byte along with the high byte. First one is a timer 0 register, which is split it as a TH0 and the TL0. So TH0 stands for the timer 0 high byte register, TL0 stands for the timer 0 low byte register. So next is the timer 1 register, which is split it as a TH1 and TL1. TH1 stands for the timer 1 high byte register, TL1 is a timer 1 low byte register. So next, this is the block diagram of the timer 0 register, which is represented from the D0 to the D7, which represents a TL0, D8 to the D15 represents a TH0. So next is a T mode register. So this T mode it is an 8-bit register, which is used to carry out either the timer operation or the counter operation along with the modes of the timers or counters. So among the 8 bits, the upper 4 bits they reserved for the timer 1 or the counter 1 operation. The lower 4 bits they reserved for the timer 0 or the counter 0. Among each of these 4 bits, the last 2 bits they reserved for the mode selection bit. Remaining 2 bits they are used to control the operation of the timer or the counter. First is the gate bit. So whenever this gate bit is equal to 1 means the timer or the counter will be enabled only when the INTX pin along with the TRX pin both should be equal to 1. INTX stands for the interrupt 0 or the interrupt 1. TRX stands for the timer run control bit. And if gate bit is equal to 1 means you can start and stop the timer by using a hardware. If the gate bit is equal to 0 means the timer or the counter is enabled only when the TRX pin is equal to 1. TRX stands for the timer run control bit. INTX stands for the interrupt 0 or the 1 pin. So whenever the gate bit is equal to 0 means the timer or counter is enabled only when this TRX pin is equal to 1 irrespective of the INTX pin value. And if gate bit is equal to 0 means you can start and stop the timer by using a software instruction. Second bit is a C/T bar pin. So when this bit is equal to 1 means it is acting under the counter mode of operation. If this bit is equal to 0 means it is acting under the timer mode of operation. So next two are the mode selection bit. M1 and M0 represents the mode selection bit. If both are equal to 0, 0 means it is operating under the mode 0 configuration. So this mode 0 configuration you want to call it as a 13-bit timer operation. So next one is a mode 1 configuration. So this you are going to call it as a 16-bit timer operation. So next is a mode 2 configuration. So this you are going to call it as a 8-bit timer operation, and it is also called as a auto reload mode. Last one is a mode 3 configuration. So this you are going to call it as a split mode. For your syllabus you have only the mode 1 along with the mode. Source for the timer. The source of the clock for the timer will be the frequency of the crystal oscillator which is attached to this 8051 microcontroller. The speed at which the timer is operating, that depends upon the frequency of the crystal oscillator which is attached to this 8051 microcontroller. The speed at which the timer ticks, so that depends upon the what is the frequency of the crystal oscillator which is attached to this 8051. And the frequency for the timer, it is always the 1/12 of frequency of the crystal oscillator. So let me see some of the problems. The first one is find the values of the T mode in the following modes. First one is mode 1 timer 1. Timer 1 means you are going to make use of the upper 4 bits. Mode 1 means the D4 bit should be equal to 1. The equivalent of this is 10H. Second one is mode 2 timer 0, mode 2 timer 1. Timer 0 means the last 4 bits. Mode 2 means the D1 bit should be equal to 1. Mode 2 timer 1 means upper 4 bits. Mode 2 means the D5th bit should be equal to 1. The equivalent of this is 22H. Last one is the mode 0 and the timer 1. Timer 1 means you are going to make use of the upper 4 bits. Mode 0 means the D4 bit should be equal to 0. The equivalent of this in hexadecimal is 0, 0. Next we'll see the second problem. Find the timer's clock frequency and its period for various 8051 base system with the following crystal frequency. First one is 12 megahertz. We know that timer's clock frequency is always the 1/12 the frequency of the crystal oscillator. For the first problem it is 12 megahertz by 12, that will be equal to 1 megahertz. And the time period is reciprocal of this timer's clock frequency. It is 1 divided by 1 megahertz, that will be equal to the 1 microseconds. Similarly for the second case, frequency is 1.33 megahertz, time period is 0.75 microseconds. For the third case, frequency is 921.6 kilohertz and the time period is 1.085 microseconds. So next is a TCON register. TCON register stands for the timer control register. So this is an 8-bit register which is used to control the operation of the timer along with the counters. So among the 8 bits, the upper 4 bits they resort for the timer operation, the lower 4 bits they resort for the interrupt operation. So let me see the upper 4 bits. First one is a TF1. TF1 stands for the timer 1 overflow flag. So when you are going to make use of the timer as a delay generator means you are going to load the initial count value to the TH1 along with the TL1 register. After loading the initial count value, the timer starts incrementing. So once it reaches the maximum value, it rolls over from FF to the 0H. After that, the timer 1 overflow flag will be set to 1. So once it is set to 1 means, so you should stop the timer and you should clear this timer 1 overflow flag. So next is TR1. TR1 stands for the timer 1 run control bit. So this bit, it is used to start the timer along with stop the timer by using a set bit TR1 instruction, clear TR1 instruction. So next is a TF0. TF0 stands for the timer 0 overflow flag. So when the timer it is used as a delay generator, so you are going to load the initial count value. So when this count value starts incrementing, it reaches a maximum value. So once it reaches a maximum value, it rolls over from the maximums to the 0. After that, the timer 0 overflow flag will be set to 1. So once it is set to 1 means you should stop the timer and you should clear this timer 0 overflow flag. So next is a TR0, stands for the timer 0 run control bit. So this bit, it is used to start the timer along with stop the timer by using a set bit TR0 instruction, clear TR0 instruction.